Welcome back, folks. So we're gonna continue with the articulations chapter. So this is the chapter we were covering, and then I covered the first three types of bone effusion, fibrosis, and cartilaginous joints in the last video. And I said that I'll be covering synovial in the next video, so that's what it's focused on. So we went over the structural categories of the joint, and we also had the movement categories for each of the joints. So we're going to start with the synovial in this video. Okay. So synovial is going to be the type of joint when you think about joints. It's synovial refers to something that has capsule. So it's a type of joint that has a capsule. And in this case, we have a synovial capsule. So I'm going to say synovial capsule here. And inside this oval capsule, this is synovial capsule, and inside this oval capsule, it has synovial fluid. It's going to say it's going to have synovial fluid, and you didn't see that fluid in any of the other types. And synovial capsule and synovial fluid is where the name kind of comes from. So, for example, synovial joint would be many examples in your body would be your knee joint, your wrist joint, and your clavicle and sternum. Even there is a synovial joint. I think I have the category sitting here. Okay, so many examples are elbow, wrist, shoulder, hip, and your knee, ankle. TMJ is a temporal mandibular joint, and the sternoclavicular joint is between your clavicle and your sternum. So you have a small synovial joint there as well. So these are freely movable. Some of you don't think it's synovial joints, but actually they are. So you can look at some of these names and figure out. And in the lab, if you are paying attention, you know where your temporal bone is. So if you think about your temporal bone, that's where your mandible is. And when these two connect, it creates a joint called temporal mandibular joint, TMJ. T stands for temporal, M for mandible, and J for joint. So that's going to be the joint that's going to allow you to open and close your mouth. So if you get lockjaw, then that means that you got something constructing your TMJ. And that's, it's not able to go ahead and open and close. And then another one, I was the sternoclavicular joint. So that's another one. This is just showing the movements you can do with some of the synovial joints. And we'll go over this at the end of the lecture, or maybe next video. So when you move your arm up and down, you can feel between your clavicle and sternum that's connected there, and there's going to be this capsule that surrounds it, and that's what allows the fluid to be in that space. And all these movements that you see over here, we will be learning about all these movements that are caused by synovial joints, and they have fluid in there, and the function of that fluid is basically to cushion the bones, and they don't damage each other from having all this movement because they move a lot. So there's the synovial fluid that's cushioning. All right, so let's look at the joint capsule itself. So here is a generic bone, um, and here's another one. It doesn't exist in real life. Just imagine two long bones, and then around that, you're going to have this joint capsule. So around those bones, you're going to have this joint capsule. And capsule is something that contains the fluid. And articular capsule, it refers to joint. So joint capsule or articular capsule is made up of dense fibrous connective tissue that covers the outside of the joint. And there's also going to be this synovial membrane here on the inner side. And then articular cartilages that are basically keeping the two bones from rubbing on each other, creating this soft surface. And then synovial membrane that's going to secrete the synovial fluid ends up on the inside here, inside your joints. That's where you're going to have synovial fluid. So synovial membrane lines joint capsule secretes a synovial fluid. So that fluid is going to be very, very clear and very slippery. So when sometimes when we dissect a cadaver, that's a really cool event when students actually puncture into the joint cavity. They see the clearest obvious fluid come out, and that's the synovial fluid, and that's usually when I invite everybody to put gloves on, get your finger in there and feel what it feels like. You can feel that it's very, very slippery, and it's basically what's lubricating the inside here, preventing the damage from the knee or the elbow, um, or for those type of joints where there's lots of movement happening. Into the synovial fluid, you also have articular cartilage, and last time we learned that two long bones, uh, it covers the end of two long bones. So you're going to have this cartilage that's going to cover the ends of the bones. That's when two bones rub against each other. You have soft cartilage that kind of cushions it a little bit, and it's going to eventually rub away, and then you have bare bones rubbing against bare bone, and that's going to be causing osteoarthritis, which I was telling you about. So this joint cavity is going to be filled with synovial fluid and basically cushion the movement that's going to happen here and prevent, and this articular cartilage is going to prevent the damage from happening. And there's also, so this is the joint cavity that's space filled by synovial fluid. So you got other things that are associated with the joint. So for example, we have connective tissue, and that's going to be the dense irregular connective tissue. The dense irregular connective tissue is basically what's going to connect one bone to the next bone. It connects the bones. And you're also going to have some tendons, and the tendons are basically at the end of the muscle. So that's your muscle basically, and it's going to have a tendon on the end. So this is your muscle, and this whitish part is the tendon. Tendon is holding the knee together. You got another thing called here that's called bursa. That's bursa. And you might not have ever heard of bursa, but bursa is basically kind of a cushion that you got in green color here. And it's like a knee pad, and it's going to cushion you if you put your knees on the ground or something like that. So those are the accessory structures. And there's some ligaments as well. And the most famous ligament is anterior cruciate ligament. So A stands for anterior, C for cruciate, and L for ligament. So that's what ACL stands for. And the term cruciate is from 19th century Latin. It means cross. So from crux or cross. So that's what's happening over here. This ligament is crossing from one side to the other. That's why it's called anterior cruciate ligament. The anterior part means it starts on the anterior part of the tibia, and then it crosses over to the back and then inserts in the posterior part of your femur. So it starts here and then it inserts in the posterior part of your femur. And that's the most famous ligament. We know about this because many athletes, they damage it, and if you step down the wrong way or twist it, or if you put too much pressure on the ACL, it damages. And this is the one that's most easily damaged, and it's most studied because there's so much money involved with this in sports and for athletes. So we have to figure out lots of different kinds of surgeries in order to repair it. So depending on the level of damage, you might need to go in there and basically sew it back up. You can see that's done here. So it's, if there's a tear, they kind of sew it back up. And if it's damaged too much, then you have to go and take some dense regular CT from other parts of your body. There was one student, they damaged their ACL and they had to take part of their patellar tendon, or part of the patellar tendon off, and then sew that in. So they used to use that to sew it in to replace the ACL. So other people, they might need to go down to maybe into lower leg and take some of the access dense regular CT, and then if it gets really bad, then they even take ACL from a cadaver, and then they use that to replace the own the ACL that got damaged. So they do ACL surgeries, and they got some type of procedure where they, sometimes if someone is having pain and they can't figure out why, they might make a incision and then they put a camera in there to look around to see if there's any problems. Um, so even if they don't do a surgery, most people, if they, wearing like shorts and you see this type of scar, it's maybe because they had ACL surgery. But sometimes they make the incision just to look around. So that might be, that also leaves you with a scar, even if there's nothing wrong that they find. So it's like an endoscope, a camera that's they gonna use and stuck it in there to see what's going on. So that's gonna be the ligament connecting the femur from tibia, but you got many ligaments in your body. So next thing we have here is you're gonna learn about is bursa. So bursa or bursae means plural. That's why it's spelled differently. Singular is going to end with a, bursa. Plural is going to end with bursae. So that's Latin. Anytime you add e to Latin, it's plural. So that's basically going to be the cushion. And we said that before, the word itis means inflammation. So bursitis means inflammation of the bursa. So you can see how big this is. It's inflamed bursa and knee. You can see that here too. So it's swelling or inflammation of the bursa, and that's what happens when you basically put too much pressure on it and it gets too much fluid, then you get bursitis. And that's the reason why you want to wear knee pads and take lots of breaks if you're working on something that requires you to be on your knees for a long time. And oftentimes, when we dissect the cadavers, the knees of the cadavers, we never found it because it's really not green in reality, so it's hard to see, and it's the same color as everything else. And if you're not too careful, you're basically going to confuse it with adipose tissue or something else. But probably the reason why we don't see it is because in dead body, it's flattened. It looks like everything else that's in there. So um, when we dissect a cadaver, it's a little bit difficult for us to find. Next thing we have is the classification of synovial joints. Now for this, you have to be very careful because in the beginning we said we have the classification of all joints, and we had 4 types of joints. And then let me see if I can show you that again. So we had these 4 types of joints. Bony fusion, fibrosis, cartilaginous, and synovial. So we were working on synovial right now. And then we had joint classification, the movement classification. We had 3 of those types: synarthrosis, amphiarthrosis, and diarthrosis. So right now we are covering the structural classification, which is synovial. And then under synovial, you have some other categories. So that's what we're going to go over now. So under synovial, we have gliding, pivot, saddle, hinge, ellipsoid, ball and socket joints. So those 6 categories. So don't confuse these with the other types like cartilaginous or fibrosis, anything like that, because you've got many different kinds so far. So synovial joints are the only ones that have these 6 types of categories. And so we're going to go and classify these. So some of these are called gliding. Some of them are called pivot, saddle, a hinge, ellipsoid, ball and socket. This is probably the easiest one to understand. So we have 6 subcategories under synovial. So the first one here is called gliding. And it's called gliding because this is what you have in your wrist when you move your wrist. So these are irregular shaped bones that are found in your wrist, and they kind of glide past each other when you move it. So these 2 bones is an example. So they glide past each other, and this is different type of movement compared to the one in your knee. In your knee, you got almost like a knuckle that's able to kind of bend, and in your wrist, you got these irregular shaped bones that just flat against each other. And when you turn your wrist, these glide past each other, and that's considered to be gliding. And that's the example from your textbook. And then we have pivot. Pivot means you're going to turn around. So think about maybe in politics, they say they pivoted their position, means whenever they said something in the beginning, now they have changed their minds. They've changed their minds. So that's where the word pivot comes from. Also from it comes from dancing. When you pivot your position, you basically go and you twist in one place. So you have pivot. So it's going to be found in your neck, this movement. So the two bones there would be atlas and axis. The atlas will have this opening in the middle. So there's this opening in the middle, and then axis has this bone in the middle called dens, and that's what creates this joint. So it kind of fits in there, and this helps you basically turn your head left and right. So that's called pivoting. That's the only place this pivoting movement is found. It's going to be in the neck. We also have saddle and hinge joint. So saddle is the one, the name comes from the horse saddle. So the shape looks like the horse saddle here. So that's the shape here. I'm not going to talk much about this. I don't have a slide for this. So I just have this picture here. It's kind of showing the saddle joint. Looks like a shape of the saddle on a horse. And then we also have a hinge joint here. Hinge is like a door. So door, you got something in the door, you got hinges, and you can open and close it. And this kind of similar movement that's happening here, and it's going to be hinge joint, which is found in your elbow. And then going back, ellipsoid or condyloid is the one that's been shown here. It's an oval shape, and it's basically your neck. In your neck, you got a bony marking called occipital condyles. So those, and these are going to articulate with atlas, and that's what allows you to nod your head. When you're nodding your head, that's the ellipsoid joint in use, and that's going to be found at the base of your neck. Last one is the easiest to understand, it's ball and socket, and it's basically going to be your hip joint and your shoulder joint. So head of the humerus in your shoulder, and then head of the femur in your hips is going into a socket, and that's going to be called the glenoid cavity of your shoulder and acetabulum of your hip. So those are the boning markings that you'll have to memorize for your exams. So those go in the sockets, and that's why it's called ball and socket joint. It's kind of a tight fit, but this is an example here, and this is the same example being shown here. So this is classification of synovial joints. Again, don't confuse these with the other types. These 6 subcategories are only for the synovial joint, which is a structural category here. Next part of the lecture talks about the movements of the joints. And this is important because later on we're going to learn about the actions of the muscles. So I'm going to create another video for this part of the lecture. So I'm going to stop this video here. So thank you guys for listening.